Hello, honors pre-calculus students. Today's learning target is to talk about what we call a mathematical combination. So in a mathematical combination, the definition is it's an arrangement of the objects or the elements without regard to the arrangement. Now, I always use this example. In the hallways we have a locker combination, but if you enter your locker combination in the incorrect order, it'll not open. So in mathematics, a permutation, order is relevant. However, in a combination, order is not relevant. So in combinations, order is not relevant or important. So I want to make sure I emphasize that. So let's take a look at a couple examples in light of that information. So here we have mathematical world, and you get to choose 2 of the 10 animals to support. So which 2 animals would you choose? Well, let's suppose you choose the rabbit and the fish. Oh, I'm sorry, you chose the fish and the rabbit. No, you chose the rabbit and the fish. Does it matter which order I say those 2 animals in? No, you're still supporting those 2 animals. So if we were to use the dash method, we might draw 2 dashes, and if we were to count, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 animals. So we might say 10 times 9, or 90. But these 90 arrangements include rabbit, fish, fish, rabbit. So because it doesn't matter, we're going to take this number 90 and we're going to divide by 2, because there's 2 different ways you could rearrange rabbit and fish. So the final answer is 45. So you could have rabbit fish or fish rabbit, so that's why you have to divide by 2. Now, let's suppose, due to a generous donation, you're now able to support another animal. So rabbit, fish, and let's pick the bulldog. No, you picked the bulldog, the fish, and the rabbit. Well, does it really matter? No. So it doesn't matter how you rearrange the letters in rabbit, fish, bulldog. And if you were to list them out, maybe it was a fish, bulldog, rabbit. If you list them out, you will notice that there are 6 different ways. What's the mathematical way of getting that? 3 factorial. So there are 3 factorial, or 6 ways to rearrange the letters R, F, and B. If we were to use the dash method, again, there are 2, 4, 6, 8, 10 animals. You're choosing 3 of them, so you have 10 choices, 9 choices, 8 choices. But in this particular problem, it doesn't matter the order, so we're going to divide by this 6. So if I were to put that together and multiply that out, 10 times 9 times 8, divide by 6, I get 120. So there are 120 ways to choose 3 animals out of the 10. And at this point, maybe you're realizing the numerator here is a permutation. That numerator that I just highlighted is 10 permute 3, and the denominator is 3 factorial. Now, what's the mathematical definition of 10 permute 3? It was 10 factorial divided by 10 minus 7, or 10 minus 3 factorial, and that's still divided by 3 factorial. So if we do a little bit of math here, that's 10 factorial over 7 factorial, 3 factorial. If I go back up to the first problem, and I were to use the dash method, it's 10 times 9, but I need to divide by 2. Technically, it's 2 factorial. You may realize this is 10 permute 2 over 2 factorial. if we were to use the definition, that's 10 factorial over 8 factorial divided by 2 factorial. And if you invert and multiply, you get the following. Now here's where I'm leading. Here, this is a combination. So we say out of those 10 objects, we are choosing 2 of them. So the abbreviation for this is 10 choose 2. So 10 choose 2 is one way you will see this written. Other people use this notation with big parentheses 10 2 with no fraction bar. If we look at the next problem that we did, some people will write, I'm going to draw this over here. So this 10 factorial over 7 factorial, 3 factorial. Out of the 10 animals, you're choosing 3 of them. And some people write it 10 choose 3. So both of these mean the same thing. 10 choose 3 in 2 different notations. Now look at the numbers here. You got 10, 3. You got 10 factorial, 7 factorial, 3 factorial. Look at this problem. 10 choose 2, or 10 choose 2, you have 10 factorial, 8 factorial, 2 factorial. So the goal here is kind of, well, what's the pattern? Suppose you had 20 animals and you wanted to choose 4 of them. I personally like this notation, 20 choose 4. So mathematically, what's the numerator? Well, if you look at the pattern, it's 20 factorial. How did we get the 8? We said 10 minus 2. So the next problem would be, or the next number would be 16 factorial. And then 4 factorial. So you can probably see the permutation here in yellow. And then you're dividing by this extra 4 factorial because you don't care about the order. Now some of you may realize that there was a button on your calculator. So let's take a look at your calculator. I'll do the TI first. So on the TI, if you had this problem 10, press math, move over to probability, and notice number 3 says N choose R. And you want to choose 2 of them. And we got 45. On the Casio, it was 10 choose, and we're choosing 2 animals, 45. 10 choose 3, so 10 choose 3 was our answer of 120. So if you want to do the problem on the screen, 20 choose 4, Ms. Gilbert and I are perfectly fine for you to use your calculator and do 20, math, move over to probability, and press number 3, choose, and we wanted to choose 4. So 20 choose 4 is 4,845. So the learning target today was to talk about different ways of choosing objects, and let's get a little summary here. So if you skip ahead a couple pages, we'll come back to the other problems. And the goal was to understand combinations. So a combination, remember, is without regard to order. So what's the mathematical formula for N choose R? And again, I like to write it N choose R. It's N factorial divided by N minus R factorial. That's the permutation. But then you divide by this extra R factorial because you don't care about the arrangement of the objects. So let's spiral back and look. So if you look at problem number 3 here, a producer of commercial wants to choose 4 athletes for the commercial. How many different options are there? So in this particular problem, if you choose Boxer Bob, Soccer Sam, Football Fred, and Sprinter Sally, does it matter if you chose Soccer Sam, Football Fred, Boxer Bob, and Sprinter Sally? No, it's still the same group of people. So there are 8 people here, and you want to choose 4 of them. So I'm going to write 8 choose 4, and I like this notation as I mentioned. Then I'm going to get my calculator out and go 8 choose 4. And when I hit enter, I get 70. So there are 70 different groups of 4 out of these 8 people. Let's take a look at number 4 and go ahead and pause the screen. You now want 5 people. So now I would do 8, choose 5. Again, I like that green notation, but if you wanted to do 8, choose 5, that's perfectly fine in blue, but I will tell you in upper level math, you tend to use the blue version, or sorry, the green version. So this time I'm going to do the Casio, or the TI, 8, math, move over to probability, and choose 5. So 8 choose 5 is 56. The learning target of today was to talk about combinations. Remember, combinations is without regard to order, and you have the formula there on your screen. I am perfectly fine as Ms. Gilbert if you use your calculator, but you do need to show what you're typing into your calculator. Let's take a look at a couple more examples together. So problem number 5. How many different 5-card hands can be dealt from a deck of cards of 52? So this would be 52, choose 5. And as I mentioned, that is perfectly acceptable for your work. So that's telling us what you're typing in your calculator. And when you do that, you get 2598960. For problem number 6, we want to form from a group of 5 women and 4 men, how many committees of 3 women and 2 men can be formed? Well, I need 3 women. So out of the 5 women, I need to choose 3. I also need 2 men. So out of the 4 men, I need to choose 2. And we need to calculate the blue number and the red number. And then the question becomes, well, what do we do with those 2 numbers? Well, this is the fundamental counting principle, that I need both groups. I need the blue and the red groups, so I'm going to multiply those 2 values. Doing that, you should end up getting 60. Problem number 7, I would suggest you pause the screen and try these problems on your own. For problem 7, it says a group of 8 men and 10 women. You want a committee of 5, and part A says all men. So for part A, you would do 8 choose 5. And to save a little bit of time, I'm not going to type that into my calculator. I would imagine all of you can type that into your calculator. I will at the end of the explanations. For part B, I want 3 men and 2 women. So out of the 8 men, I need to choose 3 of them. And then out of the 10 women, I need to choose 2 of them. And this is the fundamental counting principle, so I need to multiply those 2 values. For part C, I just want a group of 5. Well, there's a total of 18 people, 8 men and 10 women, and I want to choose 5 of them. And the more interesting question is letter D. I want at least 1 man. So there are 2 ways of doing this problem. I'd like you to pause the screen if you haven't already and think about problem 7D. For 7D, there's a couple ways you can do it, as I mentioned. If you want at least 1 man, that means you have 1 man and then the other people could be women. You could have 2 men, 3 women. You could have 3 men, 2 women. You could have 4 men, 1 woman. Or you could have all men. So one way students would tend to do this problem in letter D is they would say, all right, well, let me do problem number 1, problem number 2, problem number 3, problem number 4, and problem number 5, similar to how you did part B. And once you get all those answers, you could add them all up. Last year in class, someone said, well, kind of what's missing? Well, what's missing here is the group of no men, meaning all women. Well, how many ways can you get all women? Well, if you want all women out of the 10 women, you need to choose 5 of them. So what I have written in red is all women or no men. And if you do that on your calculator, 10 choose 5, I am going to do this one on my calculator right now, I get 252. So there are 252 groups of all women. In part C, we figure out all groups. So in part C, we figured out all groups. So if I do 18, choose 3, or so 18, choose 5. For part C, I get 8, 5, 6, 8. So part C is all groups of 5. And then in part D, we just figured out no men in red. So instead of doing the 5 problems that I have in green, a different way of doing this problem is what we call the complement. You figure out all groups and you subtract what you don't want. So in this particular problem, all groups are 8, 5, 6, 8, and then we're going to subtract what we don't want, which is no men, or all women. So doing that on the calculator, I get 8316. So the final answer here is 8,316. Again, this is a little more complicated, and there are 2 ways of doing it. You could do 5 problems in green, or you could use this idea called the complement, where you figure out all groups and you subtract what you don't want. Let's look at the last problem for this video. From a list of 10 essay questions on a test, Mrs. Quezada allows you to choose 6 of the 10. How many different options do you have? Well, out of the 10 questions, you need to choose 6 of them. So you do 10, choose 6. So 10, choose 6 is going to be 210. So this was a short video on combinations. Again, in combinations, the arrangement of the objects is not relevant, and what you see on the screen is perfectly fine for your work.